Hello Math 30-2 and welcome to your last lesson on rational expressions and equations. In today's lesson we will be using what we learned last lesson on how to solve rational equations and apply that to real word problem situations. Okay, so real life word problems. So in the first one we have Gary here who bought a package of absolute golf shirts for $648. He's a nice guy, so he keeps one for himself and gives one to his wife and four to each of his children. He then sold the remaining golf shorts for a total of $900. Okay, so now it says if there are X golf shirts, how many did he sell? Well, he keeps one for himself, he gives one to his wife, and then to his four children. So that's a total of 6 that he doesn't sell. So he sells everything except for 6. So X, the total shirts, subtract 6 is what he sells. Now it says, write an expression for the amount paid per golf shirt, or for a golf shirt. So that is going to be, he paid 648 divided by X, tells us how much he paid. Next one says, write an expression for the selling price of a golf shirt. Well, we have 900 is what he sells each one for, but he doesn't sell all X, he sells X, subtract the 6 that he gave away, or kept for himself and his family. Now it says, write an expression for the profit he makes on one shirt. Well, if you want to know the profit, that is going to be how much he sells it for, so that's the 900, subtract the amount he paid for it, or amount he paid per shirt, right? That's it. Okay, so he does what he paid, or what he sells for, subtract the amount he paid for it, will tell us the profit on each shirt. So now it says each shirt costs $12. He makes a profit, each shirt he makes a profit of $12. So it's 12, 900 all over, X subtract 6, and then we have 648 all over X. Now this should be able to help us, right? Because the amount of shirts, the average price per shirt he sold, subtract the average price per shirt he paid, gives us the price per shirt that he made, right? That's the price made. Now, last question here says, show that this equation eventually makes that. So let's do that here. I'm first going to find my lowest common denominator, okay? Now, my lowest common denominator is the same as X multiplied by X subtract 6, all right? So, that's my lowest common denominator. I know X cannot equal to 0 or 6, or actually anything less than 6, right? It has to be bigger. 0 and 6 is there, but really we know it has to be bigger than 6, because you can't have less than 6 shirts since you keep 6, and you can't have a negative number. So there we go. Now, let's try and solve this out here. So my lowest common denominator. So I'm going to multiply everything by my lowest common denominator. So we're going to have 900, not 9,000, 900 multiplied by X, and multiplied by X subtract 6. All over X subtract 6. And we're going to take away 648, or multiplied by X, or multiplied by X subtract 6. Okay? And this is all over X. And then we have, what was it? 12. There we go. So 12. All over, and all over 1, and we have X subtract 6. Okay? So we multiply these out, but before we multiply them out, let's cancel off. So it's easy multiplication. Cancel this and this, cancel that and that, and nothing can be canceled there. So I'm left with 900x subtract, we have 648x, and then a negative multiplied by negative makes it a positive, and that's going to give me, subtract 3,888. Oops, that's a plus because I said it. Negative times a positive. This here, we multiply, we're going to get 12x squared, because I'm going to go x multiplied by x is x squared, multiplied by negative 6, so that's x squared minus 6x, multiply 12 by both, and we get 72 times x. 6x multiplied by 12 is 72x. Now, let's start simplifying this here a bit. I do this, this is going to give me 252 x plus 3,888 is equal to 12x squared minus 72x. Okay, now that that's all combined, let's make one side equal to 0. I'm going to make this side equal to 0, move everything to that side. Why? Because that's positive, and I like my leading coefficients positive. It makes it easier. So we have 0 is equal to 12x squared, and then we have minus 72x minus 252x, and we have, oops, that's going to be subtract 3,888. Okay, so we're left with 12x squared, and we have minus 324 and minus 3,000. Okay, now let's divide everything by 12. So I could factor out 12 here, out of everything, divide everything by 12, so I'm left with x squared, and we have minus, that's going to be 27x, minus 324. Okay, so there we go. Now, what I'm going to do is, we could factor it using the box method, which I did last time, or we could use our graphing calculator. Okay, so now it wants us to solve that. Okay, so I'm going to use my graphing calculator. So we're going to put that all in here. So let's take a look. We have x squared, right, plus, oh, it's actually minus 27x minus 324. Now, let's take a look at my window. I know it's going to be greater than 6, so I'm going to put 0 here. Because if it's a negative x-intercept, we know we cannot use that, right? My x max. Let's take a look at my x max now. My x max, I'm going to say is, I don't think he's going to be selling them for more than $50 a shirt. Okay, so I'm going to say 60 there is my biggest. Now my y min and y max, well, how many shirts does he have? Well, I'm going to put this at maybe 100 and this here at negative 100. Okay, just so I get a little play room there, a little wiggle room. Ah, and there we go. I found my intercept right there. So I'm going to calculate my 0. Okay, so let's see, where do you see it? Ah, there's one, there's the other, left bound, right bound, enter. So I get 36. So I have x is equal to 36. Now, if I solve the full graph, I would also get negative 9, okay? Or if I factored this using the box method, and I went like this, and I have 3, 2, 4, negative, and negative 27, I will end up getting negative 36 and 9, so then I would get 12, x subtract 9, and then I'd have x plus 9, x subtract 36, so then I get 36 and 9. But now this 9 cannot work because how does he have negative 9 shirts? That just doesn't make sense. So that 9 cannot work, so he has 36 shirts. Okay? So he has 36 shirts in a package, and that's it. All right. Now, here are some hints on how to solve these problems. It says, number 1, read the problem carefully. Make sure you understand what is being said. Okay? Number 2, introduce a variable. Just make it simple. Make x or t or y, I don't care what it is, equal to something. Number 3, write an algebraic equation, okay? Or a rational equation to represent the given information. Number 4, solve the equation. And number 5, state the solution. So here's our next problem. We're looking at speed and time. Now, they use this triangle, which is distance, speed, and time. They do it that way. I always look at it this way. How fast do you go? You go kilometers per hour when you drive, right? So that is distance over time is equal to speed. That's how I think about it, okay? So distance is equal to, well, we rearrange, let's put the t there. So distance is equal to speed multiplied by time. Speed is equal to distance over time, kilometers per hour. Time is equal to, well, I rearrange these two, it's distance over speed. Okay, I just rearrange these two, and that's my time. I just look at this formula here and rearrange it. Because I always think when I go kilometers per hour. Kilometers divided by hour is speed. Well, that's distance over time. Okay, so here we go. It says, competing for endurance race, Shannon cycled for 120 kilometers and then swam for 12. Her average cycling speed was 8 times faster than her average swimming speed. Shannon took 9 hours to complete the race. Alright, so we know it took her a total of 9 hours to complete the race. So her average swimming speed, they say, let's make that equal to S. Okay? So, we're looking at distance. Okay? So complete the table. What was the distance? Well, cycling, she did 120. Swimming, she did what? 12. So always try and make a table like this. Well, you have your 3 variables, distance, speed, and time, and everything. Okay? Now, what is her cycling speed? Well, that is 8 multiplied by her swimming speed. Well, because it says here, what is her cycling speed? 8 times her swimming speed, which is S. So, what is her time? Well, time is distance divided by speed. Okay, it's always distance divided by speed. Rearranging this formula, distance divided by speed. So what is her time? Her time is 120, it's the distance divided by her speed, which is 8s, which is the same as 15 all over s. This one is 12 kilometers divided by s. Okay? Now it says write a expression in the third column that Shannon's, oh, that's already done. Okay? Or sorry, write an equation in the third column that shows it took Shannon 9 hours to complete the race. So if it took her 9 hours, that's my time, we have to go this time plus that time. So time cycling plus swimming time, right? So that's cycling time plus swimming time is equal to total time. Well, my total time is 9 hours. Cycling time is 15 divided by s. And my swimming time is 12 divided by s. We add those times together, it gives us 9. Now E, I'm assuming wants us to solve it. Yes, it says calculate the average swimming time. Okay, so we have 15 over s plus 12 over s is equal to 9. Now this is a very nice one to solve. Why? We already have a common denominator. We know s cannot equal to 0, and my common denominator is equal to s. So I have 27 over s is equal to 9. Now, what am I going to do? Multiply everything by s. Multiply by s. So these cancel off. So I get 27 is equal to 9s divided by 9 divided by 9. I get, this is going to be 3. So the speed, s, is equal to 3. Okay, so that's kilometers per hour. So our average swimming speed is equal to 3 kilometers per hour. That's it. Okay? Now, let's take a look at the next one. So the next one here, we have St. Andrew's Students' Council is traveling from Knoxtown to Harperville for the Students' National Council Conference. So based on travel alone, for their trip, they have 2 options. They could either leave tonight by bus, or they can save 3 hours by leaving in the morning using the train, which travels 25 kilometers per hour faster. Students, the distance between Knoxtown and Harperville is 150. So let's complete the table, and we're done A. So we have 150, 1,500, 1,500 for this one too. Doesn't matter. Distance is going to be the same for both train and bus. So what is the speed? If this is s, the train, it says, is 25 kilometers per hour faster. So that's s plus 25. Okay? Now what about the time? Remember, time is divided by distance divided by speed. So we have 1,500, which is my distance, divided by my speed, which is s. Here we have 1,500 divided by s plus 25. Now, there we go. So then it says determine the average speed of the express train and calculate how long it would take to travel between Knoxville and Harper by express train. So what is the average speed? Well, we know there's a 3-hour difference between these two, right? So this fast one, subtract the slow one, this is going to be 3 hours difference. So the slow one, subtract the fast one, actually we're going to have to go. So this is the fast, that's the slow. So the slow one is 1500, okay? And that is all over S. And we subtract 1500 all over S plus 5. You know it's, or 25. Ooh, 25. We know it's 3 hours because it says they saved 3 hours by taking this. So this is 3 hours faster. So then this minus that gives us 3 hours. Okay? So now, looking at this one, we have different denominators, right? We actually have 3 different denominators. So my lowest common denominator is equal to S, and then S plus 25. Okay? So I'm going to multiply everything by S and then S plus 25. So we have 1,500 multiplied by S and then multiplied by S plus 25. All over, we have S. And then we're going to subtract 1,500 multiplied by S. Then we're going to have S plus 25. All over S plus 25 is equal to 3. And we have S. And here we're going to have S plus 25. Okay? Now, what can be canceled off? We know S cannot equal to negative 25 and 0. That makes sense. We can't have a negative speed and we can't be going 0 because then we'd never make it there. And I'm going, okay, so let's cancel off, cancel off, cancel off, cancel off. So I'm not even going to deal with my non-permissible values right now just because of that silliness. And let's multiply these together. So 1,500 times S, which is 1500S. And then that times 25 is going to give me plus 3725, I think. I'm just going to double check. 1500, and I'm going to multiply that by 25. Yeah, 3750. Just double checking, and we're going to have to subtract 1500S. Gives me right here. Let's take a look at this here. We have 3S squared plus 75S. Okay, now, let's see, what can we cancel off? This and this cancel off, and I can move this to that side, so I end up getting 0 is equal to 3S squared plus 75S. And then I have subtract 37500. Okay, now, this is nice. I could factor out a 3, can't I? So I'm going to factor out a 3 of everything. I'm going to be left with S squared plus 25S. And I'm going to use this 15, so 500 and 12500. Okay, because that's 500 times 25 is that. All right, now, I could factor this, which shouldn't be too hard, or I could use the graphing. Okay, so we could use the box method and factor, where I'd have 1, 2, 5, 0, 0, negative, and we'd have, what is it there? 25. And figure out what to make that. Okay, we know there's a difference. So it's a big one and a small one. All right, now, and that should be easy to do, or we could graph it in our calculator. All right? If I look at this difference of this I think is easier because we could have 100 and 125. Well, right there is a difference of 25. Okay? If I just factor that out, and I would say that's negative, so I'm going to say 3, and I would go S minus 100. And then S plus 125, and this S was for the bus, right? So I look at this here. What do I end up getting? The bus is 100 kilometers. S is equal to 100. It cannot be negative 125 but it cannot be this because you can't go in negative kilometers per hour, so it's 100. You could have done it in your calculator, and if you did this in your calculator, I strongly suggest your x values be between 0 and maybe 150. I would even put 200 because you don't know if it's a high-speed train, but the bus thing right there, 0 and 150, because, well, it's not going to be 10 kilometers an hour. We can even say 50 and 150, just for the average, okay? Because I would have guessed 80, but 100 seems right. So 100 kilometers per hour is the bus. So 100 plus 25 is going to give me my train. So I get 125 kilometers per hour is the train. And that is my answer. Okay? Then it says, calculate how long it would take to travel between Knoxville by train. So what do I have to do? As I go 1,500, I'm just going to write this down here, 1,500 divided by, the train is 125, which will give me, 12. Which will give me 12 hours, I believe. Okay? And that's everything. Okay, I almost forgot. Good thing I reread that question because I almost forgot to answer the total question, which was how long does it take by train? So there's everything. If you are stuck on anything, feel free to ask me tomorrow as we work on this together. This one I strongly suggest doing a lot of questions, a lot of practice. The more you do them, the easier it will get. See you tomorrow.